Good morning, dear students. Today we're going to go ahead with the next part of investment decision, that is modified internal rate of return. In the previous video, we have studied how to calculate internal rate of return. In that, we said that internal rate of return is calculated using trial and error method. Modified internal rate of return is a modified version of IRR where there is a fixed formula and there is a fixed methodology. Here there is no trial and error. So let's go ahead to understand what is modified internal rate of return. First of all, modified internal rate of return, the formula is TV divided by PVCO, the whole raised to 1 by n minus 1. TV stands for terminal value. TV is terminal value. Then PVCO, that is present value of cash outflow. So there are two terms that we need to understand here. That is terminal value. Terminal represents at the end. Okay, so terminal value would be the value at the end of the project, and present value of cash outflow is the value at the beginning of the project. N represents number of years for the project. So modified internal rate of return, basically what happens here is when you get the inflows and you reinvest them, none of the other methods that we have studied so far take that into consideration, whereas modified internal rate of return considers the reinvestment. So whenever you get the inflows, they are reinvested is what is assumed in modified internal rate of return, and similarly the calculations are done. So let's understand modified internal rate of return through two problems. First problem, calculate MIRR for the following if discount factor is 10%. Now here discount factor is clearly mentioned to us. If you remember, in IRR discount factor is not given. We assume through trial and error and then arrive at two rates, that is low rate and high rate. That is not the case with MIRR. In MIRR discount factor is directly been given and we have to use it directly in the process. So calculate MIRR for the following if discount factor is 10%. Year 0, 16,000, 1, 8,000, 2, 7,000, 3, 6,000. So years are given and cash flows after tax are given to us. Now how do you go about this particular problem? First is we need present values of cash flows after tax, or present values of cash outflows. Now what is an outflow here? 16,000 is an outflow. So we need to find out the present value of this outflow. Now if you have understood present value correctly, the 16,000 is invested at 0 period. 0 period itself is the present value or the present period. That means the 16,000 itself would be your present value of cash outflow, because n would be 0 in that case. So in the formula we require present values of cash outflow. So we have already calculated present value of cash outflow, which is 16,000. I hope you're clear with this calculation of present values of cash outflow. Now coming to the next part, that is we need to find out the terminal value. Now how do we find out the terminal value? Terminal value is at the end of the project. So we need to find out future values here, future values of lump sum. So what do we do? 60,000 we have to find out the future value, 70,000 we have to find out the future value, and for this 80,000 we have to find out the future value. Now to find out future value, most important thing is the value of n. What would be the value of n? Future value means at the end of third year. So at the end of third year means at the end of third year means that at the end of year 3. So at the end of year 3 means the year 3 cash flows, which is 60,000, we have to find out the future value of that. So what would be n in that case? N would be 0 because it's already in the future. The 60,000 is at the end of third year. So this is already the future value. So n would be 0. If you remember the formula of future value of lump sum, it is future value is equal to present value into 1 plus I raised to n. So here we know present value is 60,000 plus 1 plus I is 10%, and raised to n would be 0 in this case because we need to find out the future value at the end of third year. This is the value at the end of third year itself. So n would be 0. Whereas for this 7,000, n would be 1 because we are moving 1 year ahead. Whereas for 8,000 we are moving 2 years ahead. So 1 and 2, n would be 2. I hope you're clear with this calculation of n, which is very important here. Okay, I'll repeat. For year 3, which is the last year, n would be 0. For year 2, which is the last second year, n would be 1. And for year 1, n would be 2 because we have to move 2 years ahead to get the future value. So this is how n is calculated. So once n is calculated, use the formula present value is equal into 1 plus I raised to n, okay, and get the values, future values. So these are the future values. So 6,000 into 1 plus 0.10 raised to 0. So 1 plus 0.10 raised to 0 is 1. So 6,000 into 1 becomes 6,000. So 6,000, 7,000 into 1 plus 0.10 raised to 1 would be 7,000 into 1.1, that is 7,700, and 8,000 into 1.10 raised to 2 would be 9,680. So once you add all these future values, you get the terminal value. So 6,000 plus 7,700 plus 9,680 gives you 23,380 rupees, which is the terminal value. Now let us use this in the formula. What is the formula? MIRR is equal to terminal value divided by present values of cash outflows raised to 1 by n minus 1. So the terminal value is 23,380 divided by the present values of cash outflow is 16,000 raised to 1 by n. N is 3 years. There are 3 years for this particular project. So n is 3. So 1 by 3 minus 1. So 23,380 divided by 16,000 gives you 1.4612 whole raised to 1 by 3 minus 1. Further, if you simplify, it is 1.1348 minus 1, which is 0.1348 or 13.48%. So the MIRR for this particular project would be 13.48%. Okay, I hope you're clear with the calculation of these future values and this present value. Okay, here in the previous basically in previous all methods we just use present values. We have never used future values, but in this particular method we are using both the future value of lump sum as well as the present value of lump sum. So be careful when you're taking it. Okay, so I have shown these arrows because we are going to move forward, so future, and here it is backward, so present. Okay, so again I'll repeat. First find out the present values of the cash inflows, future values of the cash inflows, that is 6,000 in 6,000 for 0 period, 7,000 for period 1 for n1, and 8,000 when n is 2. And then find out the terminal value, that is the summation of these three. You already have the present values of cash outflow, which is 16,000 because it is n, here n is 0. So it remains as it is 16,000. So use it in the formula and get the answer. This is how you calculate MIRR. There is another method to calculate MIRR. It's similar, but we don't use this timeline. Let's understand that also. And whichever you find easy, follow that particular method. So let's take this problem. Calculate MIRR if discount factor is 10%. So here is given 0, 1, 2, 3, 4 and cash flows after tax are given. That is minus 1 lakh, that is initial investment, that is cash outflow. Then 20,000, 30,000, 40,000 and 50,000 are your cash inflows. So what do you do? For the outflows, you find out the present value. So present value of 1 lakh would be 1 lakh itself because it is at 0 period, right? Then the future values of the inflows, that is 20,000, 30,000, 40,000 and 50,000. We have to find out the future values. So how do you find out future values? It is 20,000 into 1 plus 0.1 raised to 3 Why 3 now? If you see 1, 2, 3 and 4. This is the timeline for this particular project, 4 years. So for first year's cash flow, how many years we have to move ahead? 1, 2 and 3 years. So here n is 3 over here. Okay. For the second cash flow, that is 30,000, n would be 2. Why? Because if you see the timeline again, it is 1, 2, 3, 4. This is year 2 where the cash flows are 30,000. 30,000 is the cash flows. So how many years we are moving ahead? 2 to 3 and 3 to 4. Only 2 years, right? So n would be 2 in this case. For third year, it would be only 1 because yes, you're just moving 1 year ahead. This is 1, 2 and 3 and 4. Okay. Third year cash flow is 40,000 and n would be what? You're just moving 1 year ahead. So n would be 1 in this case. And similarly for year 4, n would be 0 because you are not moving ahead. That is the time where you are going to calculate it. So this is how we have calculated the n values, that is 3, 2, 1 and 0 for various years. Then solve it. 20,000 into 1 plus 0.10 raised to 3 and multiply, solve it. You get the present values, future values of the cash flows, that is 26,620, then 36,300, then 44,000 and 50,000. Once you get this, add all these future values because we have to calculate the terminal value. So summation of future values of cash flows after tax gives you the terminal value. So terminal value is 1,56,920 and your present value of cash outflow is, the summation of these terminal value future values of cash flows is 1,56,920 and your present value of cash outflows is 1 lakh. Now we have got both the variables, that is terminal value as well as present values of cash outflow. Find out the MIRR. So MIRR is, I'll repeat the formula once again. It is terminal value divided by present values of cash outflows, the whole raised to 1 by n minus 1. So terminal value is 1,56,920. Present values of cash outflow is 1 lakh. So 1,56,920 divided by 1 lakh raised to 1 by 4. Why 4? Because number of years are 4 years. So 1 by 4 minus 1. If you further simplify this, you get the MIRR as 0.1192 or 11.92%. So this is how we calculate MIRR. I hope you're clear with this calculation of MIRR. So with this, we come to the end of the individual methods of investment decision. In the next video, I'll be talking about a problem where CFAT is not given. Okay, they have given cash flows before tax. Now, how do we convert cash flows before tax into after tax and use it in the formula is what we are going to see in the next video. Till then, thank you.